Okay, let us study Fermion Propagator. And in previous class, we have derived the equation of motion for spin 1/2 particle under electromagnetic interaction was expressed like that. And putting this one to be some kind of current, that we have derived the Fermion Propagator for the spin 1/2 particle is S of F, and the result was right? And if we make use of that fact, then we can determine the change in wave function psi of x is written like that. It is not easy to understand immediately. However, if you substitute this one to this equation, you will find what it is. And this operation is made to psi, then integral over dy s of f x minus y j of y. And this, this is acting on the x variable. So this derivative is with respect to x only, and it is independent of y. So this derivative acting on s of f only, okay? And derivative to this is, by definition, it is x, then delta x. But actually, if we make use of s of f x minus y, then the result is delta x minus y. Understand? Okay, because with respect to x, y is just constant, so we just shift the amount by y. So this is replaced by, this one is replaced by delta x minus y. And after multiplying to the current, this becomes j of x. So we have found that psi of x satisfies the Dirac equation with the source. So psi of x is now re-expressed by substituting the full expression for the current j of y. I have Fermion propagator and this vector. This x and y, they are different. This one clearly shows that there's a Fermion state. Once Fermion state is applied by some gauge field contribution due to the current, the interaction with the charge of the spin 1/2 particle couples to a photon, and then it propagates to different space-time position x. And the final state wave function for the electron is like that. At some point, a electron, there was only a single free electron, but at some point, it can be interpreted to be sum of electron and photon. Because charged particle can interact with photon, so number of photon is not conserved. But we can clearly see number of electron is conserved. Okay? All right. By the way, what was the Lagrangian density function at point x? At point x, minus q psi bar, position x, and a/x psi x. And let us substitute psi of x, this result, in there. If I substitute psi of x, not psi bar, in here, it is integral over y, Fermion propagator from y to x, and gauge field with gamma matrix multiplied at point y and multiplied by psi of y. You remember T matrix element is just I times the space-time integral of interaction Lagrangian. So we can integrate over x2. Then I is here. I have a single I. I means minus 1, so it is a minus I. Minus I is here, and I do not have any vector, so let me make use of our convention. Put I and minus I. So this one looks like just the Feynman rule. And this one is the vertex, another vertex, and propagator. Let us expand everything. So A, two photon field, A mu x, A nu y. And the expression is now integration over x and y. That means I have for example, electron is going up, and at point y, it meets some photon. Suppose I have electron and photon collide together, and then photon disappear, and it propagates the new electron. E star, that means a virtual state. You know, energy, this mass is not, the rest mass is not the same as its own real particle rest mass, because the two energy combines and E star has the wrong mass. And then propagates with S of F. And at some point x, it becomes a final state of electron. So it becomes electron, final state electron, and it is emitting photon. This is a kind of Compton scattering, but actually we have to integrate over x and y. And you know, this A, they are undistinguishable in this expression. I don't know whether this photon is incoming, this photon is outgoing. It is also true that it is outgoing and it is incoming. There are two possibilities. So I have another amplitude. Outgoing first and then incoming later. This is the expression summarizing the Feynman rule. So electron, photon meets and they collide, and the final state is also electron and photon. Then this is T matrix element. And actually invariant amplitude is what? You know, there is these wave functions have the momentum space wave functions and the oscillating vectors and momentum space projection. They are usually in the particle, positive energy particle, electron case, we have U spinor. So psi is a UP2 minus IP2, and vertex is at Y, something like that. And if this is incoming photon, it will have wave function, polarization backfold vector with momentum P1 and exponential minus I P1Y. For the case of this interaction, I have a mu of x is replaced with the final state wave function polarization vector complex conjugate multiplied by e to the plus I k1 dot x, that is final state wave function. And electron's final state is u bar with momentum k2. And each vertex have a gamma matrix. And you have minus I charge gamma matrix, minus IQ charge, I charge gamma matrix. In the intermediate state, I have to multiply Fermion propagator and integration over momentum with minus I P1 plus P2 dot x minus y, right? From y to x. But these kind of exponential factors are all combined together to make energy momentum delta function. And actually, if I write down the invariant amplitude only, that is necessary to know to compute the cross-section, something like that. Let me write it M1 and M2. Just let me write just M1 only. Then M1 outgoing U bar K2, right? And there's a vertex minus I Q gamma mu, right? And then propagator I, what is the momentum? This P1 and P2, they are combined to have a single momentum. So the total momentum is a P1 plus P2. And then there's a gamma matrix. And initial state wave function. And wave function for the two photons. Multiplied by epsilon mu. Outgoing is a star, K2. And epsilon u with momentum P1. So this is the invariant amplitude for this diagram. If you consider this diagram, everything is the same except that we have to replace this vertex and momentum, right? Okay. If you this is the T matrix element, contains everything allowed by the theory, and actually we can treat the case E plus meets a photon to make E plus and photon. In that case, we can make use of negative energy solution for the electron. Then it is going backward. Okay? I have explained everything now. We have constructed the invariant amplitude for E minus, mu minus to E minus, mu minus, E minus, mu plus to E minus, mu plus, and now E minus photon, E minus photon, and E plus photon, E plus photon. Okay. That's it. Thank you for listening.